UN 영어뉴스 염염 yellow. Could your swimwear attract sharks? Sharks were long thought to have poor eyesight, but recent research is revealing new insights into their ability to see colors and if they can distinguish prey from people. Rescue equipment is the color it is for a very good reason. A splash of orange or yellow stands out against the blue and black of the open ocean. This flash of color might be the only chance a floating sailor or air crash survivor has of being spotted from a passing ship or plane. But what else might be attracted to these bright colors on the water's surface? The US Navy finished World War II with a great deal of eyewitness accounts of shark attacks on sailors and airmen who had found themselves cast into the ocean. These included the sinking of the USS Indianapolis near the world's end, which resulted in possibly hundreds of survivors being picked off by sharks. The Navy's scientists knew that sharks were attracted by the splashing of survivors and the blood from injured or dead sailors. But what if the color of their life preservers played a part as well? The hunch that the bright colors of the Navy's life-saving equipment attracted sharks led to some dubbing the color yum yellow. The propensity for some colors to attract curious sharks has become a particularly long-lasting myth, resurfaced whenever a spate of shark attacks takes place. This month, there have been reports of a spate of people being beaten off the beaches of New York's Long Island, raising questions about what might be behind the incidents. The shark species involved, the normally docile and aquarium-friendly sand tiger, mainly is fish and crustaceans such as lobsters. It is thought that the bites could be the result of mistaken identity. The sharks are confusing the arms and legs of swimmers for the fish it hunts in shallow summer waters, or exploratory behavior by a curious animal. The benefits of shark sightings. While the exact reasons for shark attacks are often complex and still not fully understood, could the color of swimwear, surfboards, and other equipment play a role, as the US Navy suspected? Sharks are blessed with some senses that seem almost supernatural compared to ours. Sharks can detect smells at range between 1 part per 25 million to 1 part per 10 billion, and can sense movement in the water via a line of sensors which run across their body and the electrical signals from thrashing fish. But what about eyesight? Sam Gruber, a prominent shark scientist who set up the American Elasmo Branch Society, was one scientist who put shark eyesight under the microscope in this 1970s era video for the US Navy, menacingly titled Sharks: The Danger in the Sea. Gruber, who died in 2019, recounts, "I became interested in the vision of sharks when the Navy came to us with the following story. In an air/sea disaster, pilots were wearing orange suits, while the crew was wearing green khaki suits. Pilots, to a man, were attacked by sharks, apparently because they were wearing orange suits, while the men in the green suits were left entirely alone. Some shark species, like lemon sharks, show an ability to discern certain colors better at certain times of day." Gruber and his team's studies showed that, like humans, sharks can discern light from dark and have excellent visual acuity. We showed that some shark eyes contained both rods and cones. Rods are useful for detecting movement and discerning contrast, while cones are able to render both color and fine detail. Previous literature on sharks suggested that most shark corneas contained only rods, and that they might only see a poorly lit, monochrome view of the world. This turned out to be true of sharks which lived in deeper waters, where color and fine detail is less important than sensing movement. However, Gruber found other species, like the great white shark, had a higher concentration of cones, which meant they could see greater detail and discern color better. The pelagic species blamed for most attacks after ship sinkings and plane crashes, like the oceanic white-tip, however, have relatively few cones, says Gavin Naylor, director of the Florida program of shark research in Gainesville, Florida. It's been explored most rigorously by Nathan Hart in Australia, who's a physiologist. He has looked at the retinal profile of different sharks and sees what colors they can perceive, and what Nathan has found is that most sharks, pelagic sharks anyway, can't see color very well at all. Hart is an expert in shark senses at Macquarie University in New South Wales, Australia. He has examined not just the arrangement of cones and rods in shark eyes, but also the presence of light-sensitive proteins known as opsins that allow animals to distinguish color. In a review of the most recent scientific research on shark eyesight, he concluded that many, if not all, of the shark species studied to date have monochromatic vision and appear to have lost the ability to see in color at a number of points during their evolutionary history. But this doesn't mean that sharks have poor eyesight. Some bottom-dwelling species of shark, for example, appear to have heightened sensitivity to contrast compared to other vertebrate animals. According to Hart's work, water quality can also contribute to this. In clear water with bright sunlight, sharks will be able to discern objects better. Ocean-going sharks, like the blue shark and the oceanic white-tip, often hunt near the surface, where light quality is usually good. Research on great white shark attacks has revealed that they are often more likely to occur in turbid water conditions, where the water is far less clear. One recent study, led by Hart and shark sensory biologist Laura Ryan at Macquarie University, used underwater cameras to replicate a shark's eye view of swimmers and surfers in the water. The scientists concluded that the shape and motion was hard to distinguish from that of the seals that are the main prey of great white sharks, and in turbid waters this difficulty could be increased. Great whites have eyes with more cone cells in their eyes than many shark species, which lets them discern color better. The likelihood is that if you can't see the shark, Naylor says, it can't see you. But there are some patterns or combinations of colors much easier to discern underwater. If you've got some pattern, like a Secchi disc for measuring water turbidity, for example, which is black and white, you have a much better chance of seeing it at a distance than if it was in camo greens and yellows. What Nathan has shown is that it's not really the yellow, but yellow when it's juxtaposed with particular patterns against darker colors, he says. So it's the contrast that they can pick up on. Some of Gruber's experiments in the 1970s looked specifically at the colors sharks might be able to differentiate. Lemon sharks, a species which spends a lot of its time in shallow waters, like mangrove swamps, were found to be more susceptible to green colors in the evening and yellow in the daytime. This is a widely observed phenomenon in animal eyesight called the Perkins shift. Armored eyes. The world's largest living fish, the whale shark, has developed an extraordinary adaptation to help protect its eyes. These huge sharks have armored, rigid denticles that help to protect it from damage. They also have the ability to retract their eyeballs back into their eye socket by more than 3 centimeters. Whale sharks have relatively small eyes, just 6 centimeters, compared to their body size, which can reach over 18 meters. This has led many researchers to conclude that they had relatively poor eyesight. But Japanese scientists who studied the whale shark's eyes in more detail argue the armor and retractable eye suggest they are more important than previously believed. Some research has also shown that whale sharks' eyes can track divers up to 6 meters away and may play a key role in short-range vision. Sharks' eyes also share a feature that cat owners might be familiar with: a reflective layer of crystalline substances at the back of the eye, called tapetum lucidum. This layer acts like a mirror, reflecting light that would otherwise be lost back into the eye, helping to enhance vision at low light levels. Some species of sharks' eyes shine when exposed to a bright light source in the dark, in much the same way a cat's will from a burst of light, such as a camera flash. Some reef shark species, for example, hunt at dusk or during the night, and this adaptation may help them. And while sharks benefit from a wide range of other heightened senses, research so far shows not all shark eyesight is the same. Great whites, in particular, seem to depend on eyesight more than other species. Pioneering shark conservationist and underwater photographer Valerie Taylor experimented with a wetsuit in the 1970s, which mimicked the banded markings of certain sea snakes. Some shark species avoid these venomous reptiles, but not all sharks are put off. Tiger sharks, in particular, are keen predators of sea snakes. In 2013, a company called Shark Mitigation Systems offered an update of Taylor's banded suits, claiming that they could significantly reduce the risk of an attack. The company offered two suits, one a banded one, which mimicked sea snake markings, and another which alternated blue and gray to help the wearer blend in with their surroundings. But neither suit was a one-size-fits-all solution. The gray and blue suit wouldn't have deterred great whites, which look for silhouettes on the surface and attack from below, and the banded suits wouldn't have scared off tiger sharks. So should those who have spent time on the waves ditch their yellow or other brightly colored equipment in favor of something a little duller? The International Shark Attack File's own device is that the benefit of increasing one's chances of being rescued far outweighs the minimal risk of attracting a shark. There is no current guidance for swimmers to turn their wax on brightly colored swimsuits and accessories. However, it also adds, alternatively, divers and swimmers can probably reduce the chance of an interaction with a shark by avoiding bright and highly contrasting swimwear or dive gear. We personally prefer to use dark blue or black fins, mask, tank, and wetsuit while diving. Some high-profile surfers have chosen to abandon brightly colored yellow boards in favor of black and blue ones in an attempt to avoid attracting the attention of sharks. Hart says while the sharks themselves may not be able to distinguish between one bright color and another, reducing the contrast with the surrounding ocean could help in some situations, but he says for sharks that attack from below, such as the great white, a surfboard silhouetted on the surface would still stand out dramatically. Naylor says the color of bathing costumes may also not be as important as items such as watches, which can catch the light in the same way as fish scales and can be a factor in some unprovoked attacks. The International Shark Attack File's advice is to tuck a watch underneath the cuff of a wetsuit. Naylor has even seen the lenses of cameras underwater inspire an attack during a dive by shark scientists who were taking part in a convention in South Africa. This woman was passing a GoPro to her partner, and he was going to pick it up, and the shark came and bit her on the finger. It's because the GoPro is a shiny little wizard. Sharks' curiosity towards some bright colors and contrasting patterns may be part of their inbuilt hunting instinct, passed down over millennia, says Naylor. They've got to deal with the patterns and respond to them. Sharks also learn by trial and error what gets them their next meal and what doesn't, and those experiences take time to learn, says Naylor. I think a lot of the juvenile animals are responsible for bites because they haven't got as much experience as the older animals. I think that the adults are more discerning and target their appropriate prey. If you have a predator that can't deal with context-dependent situations, it's going to die. So it really behoves them to look, to be able to learn, and to adopt strategies that ensure that they can get fed.